Good day and welcome to all in attendance. I hope you and your loved ones are all safe during this period of the COVID-19 pandemic. My name is Ms. Bakhan Osman, and today on behalf of my associates, I will be presenting to you a comprehensive analysis of sustainability within the built environment. This shall be carried out with specific emphasis on digitalization by the use of robotics in 3D printing. The fourth industrial revolution has given rise to advancements in artificial intelligence, robotics, the Internet of Things, and quantum computing, which, when combined, paves the way for transformative changes in almost every business sector. Building on these technological fields has allowed other industries to adopt digitization practices into their everyday routines. Large companies such as Amazon have seen great success in the incorporation of artificial intelligence and robotics. The most fascinating aspect is that Amazon has more than 200,000 mobile robots working within its warehouse alongside human workers. The motivation behind the inclusion of robotics sought to meet the company's goal of providing speedy deliveries to their ever-growing Amazon Prime customers. With its inherent complexity, construction is regarded as one of the most dangerous industries greatly susceptible to various unpredictable factors. By identifying, evaluating, and reacting to potential risks in dynamic and hazardous construction environments at an early stage, it is expected to eliminate safety hazards and achieve a sustainable reduction in fatalities in the industry. Furthermore, as we move towards Industry 4.0, constant innovations towards digitalization can be used to realize considerable boosts in automation, productivity, and reliability. Regarding the construction industry, widespread technological practices may be adopted to improve sustainability and efficiency. In particular, the industry may see advantages such as better creativity, design flexibility, reduced material waste, minimal carbon footprint, and more robust structures through the capabilities of newer technologies. However, the construction industry has traditionally been conservative in adopting new technologies and tends to divert from contemporary practices for selected projects only. Herein lies a gap that the inclusion of robotics such as 3D printers seek to fill. The first 3D printer was created in 1984 and have since seen rapid improvements in its design and capabilities. In particular, various industries have shown interest in these machines as they allow for fast prototyping of new products. Due to the previously mentioned reason, there has been an increasing interest tied to printing materials and 3D technology improvements. The printing process is somewhat similar to that of standard office printers. The initial step to 3D printing starts on a computer where a 3D model is created and converted to an acceptable format. Thereafter, thermoplastic material such as biodegradable plastic is heated by the printer until it reaches a liquid state. The liquid is then laid iteratively by the nozzle of the printer in order to create multiple layers. Consequently, this leads to considerably less scrap waste, approximately between 70 and 90%, as compared to some traditional manufacturing methods. The most important task in 3D printing is to develop a material that will be flexible enough to create multiple layers, adhesive enough to join subsequent layers to the previous one, and stiff enough so the component can preserve its shape. 3D printing can be considered as a form of additive manufacturing, which is an emerging technology through which raw materials are deposited on a foundation in layers via a nozzle which is attached to a robotic arm. The advantage of such a design will allow for unrestricted movement in 3D, which will further allow the deposition to form complex designs. Regarding additive manufacturing processes, concrete deposition is one of the most popular approaches in modeling aggregate-based materials. The printing process is identical to the one mentioned earlier. However, the concrete mixture must be designed compatible with the printing machine. The resultant mixture is deposited in layers through the robotic features, which results in a more efficient process. Regarding the performance of 3D printed concrete samples, the consensus is that 3D printed concrete has a similar compressive strength to conventional concrete. Furthermore, other factors such as the loading pattern may affect the compressiveness of the 3D concrete. In particular, loading in layered and loading in perpendicular alignments may play a role. Printed samples are usually layered, thus bonding factors are hugely important. Various factors affecting the strength of interlayer bonds include viscosity, the printing time gap between the layers, the contact area between the layers, and the setting time. A revolution in the construction industry started in 2014 when the first printed house, known as the Canal House of Amsterdam, was created. A Dutch company designed the Canal House in Amsterdam, in which they sought to leverage the benefits of 3D printing to develop parts of the house on site. This project aimed to identify the feasibility of 3D printing in the built environment. Furthermore, they sought to eliminate building waste and minimize transportation costs. The timeframe for the Canal House project was estimated in order to allow designers to understand the process of 3D printing and component modeling thoroughly. The variations in 3D printing used in construction include contour crafting, concrete printing, and D-shaped techniques. The realization in each technique to suit specific tasks provides a basis for the future experiments to be conducted and evaluated. 3D printing in the construction industry is relatively young and presents a lot of limitations. However, there are high hopes for the 3D use of printed buildings and building components. Incorporating 3D printing will require a change from the construction industry, as newer environmentally friendly alternatives will replace more contemporary materials. Furthermore, through mathematical modeling and in-depth design, architectural challenges will be easily overcome, and this will further allow expressive designs while maintaining sustainability in material selection and construction. The innovations provided by 3D printing results from the industry's movement towards environmental and social sustainability. Some advantages include lower costs, environmentally friendly construction processes, reduced on-site injuries, reduced project turnaround time, and modularity. However, there are still many doubts and anxieties surrounding 3D printing, as newer and rigorous processes must still be in place in order to ensure project success. These include detailed computerized designs and modeling at an earlier stage in order to avoid failure during production. The following slide will showcase a time lapse of the 3D printing process, which is executed by Robotics in Dubai. With construction costs and clients' demands forever rising, the use of digitalization in the construction through robotics and 3D printing is very much needed. It lowers the overall cost of a project by using more environmentally friendly materials. The time duration is also decreased because the method used reduces labor needs while increasing productivity. The digitalization of construction would be far less have a negative impact on the environment than traditional construction methods by lowering wastage by means of using materials that are fully recyclable. The future of 3D printing within the construction industry is hopeful and exciting. It will soon lead to the use of smart materials, which will make it more enticing to use, and therefore it will eventually lead to smarter designs and buildings in order to achieve a greener future for society. Will 3D printing and robotics benefit society and add to sustainability? The answer is yes, it would. However, the question still remains, will it also render professionals becoming obsolete? Only time will tell as the generation enters into the era of 4.0 encompassing artificial intelligence. And lastly, don't be surprised if you find robots showing up at your construction site. No, it will not be a sci-fi movie, but in fact an inevitable reality. Thank you all for listening.